Can domain of square root function be all real numbers? That's a good question to ask. Normally, when we consider square root function, we write f of x equals to square root of x. And that is indeed the basic or the parent square root function. And the graph of this function is kind of like this. Now in this particular case, as we know, domain is indeed all real numbers but greater than or equal to 0, right? So domain is restricted. Domain is x belongs to real numbers where x is greater than or equal to 0. And therefore, that gives us an idea that even a transformed function of this kind will have a restriction since the parent function has a restriction. Now let's take some examples where the domain could be all real numbers. Now the reason for this is that x within the square root, anything within the square root cannot be negative, right? So if I write another function h of x, for example, equals to square root of f of x. Now in this case, f of x should always be greater than or equal to 0, right? That is why we have restrictions, right? That leads to restriction. So this is the reason of restriction. Correct? But if I give you a function f of x, which indeed is positive all the time, for example, imagine f of x equals to x squared. Now this function will never be negative, correct? And therefore, h of x, which is square root of x squared, is possible, right, all the time. So in this case, we have a domain which could be written as x belongs to real numbers, right? So in this case, what we see is we have no restrictions. So there are cases when we may not have any restrictions, correct? Can you sketch this function? So that could be a good exercise. So my problem to you is, question, sketch. H of x equals to square root of x squared, and show that it has no restrictions at all. I hope you appreciate it. Thank you and all the best.